Hello guys, welcome to Ramtel Solutions and welcome to your grade 10 electric circuits. Today we are looking at resistors in series. Okay, we are looking at resistors in series. So we are going to derive some important formulas, and please follow through so that you make sense of everything that we are saying. Okay. And by following that, you will be set for the rest of your life. So you guys can draw this circuit. I'll give you maybe 10 seconds. You can draw this circuit and we'll talk. Yes. Or maybe 10 seconds is not enough. I'll give you extra 10 so you can draw it. Okay, I think it's enough now, so I believe, but it's okay. I will just keep talking so that some of you can finish. Now remember, we said when you come to electric circuits, you need to remember that current flows from the positive terminal. Now, the longest arm is the positive terminal and the shortest, maybe let me use a smaller font size. This is the positive and this is the negative terminal. So I'm saying current flows from the positive terminal. So from the positive terminal, you should draw an outward arrow like this. This is to say to you, current is flowing in this direction. Now, in the opening video, we said current gets divided across joints. And we also said current does not flow along the voltmeter. So you can't say current is divided here. So as you can see, current is flowing here. It is not divided. It's coming in, out, in, out, in, out. It's not divided, right? So for resistors in series, let's say now, it's not let's say, it is, we have seen current is not divided, all right? Current is not divided, all right? So if we say current is not divided, let's say the current that's flowing from this cell, or sort of from this battery, is basically I'm gonna say I sub T, meaning total current, okay, which is also the same current that's measured by the ammeter here. It is equal to the current that's flowing in, I don't know why I changed the orders. Maybe I should have said 1, 2, 3, but it's fine. It is the same as the current that's flowing in resistor 1. It is the same as the current flowing in resistor 2. It is the same as the current flowing in a resistor 3. It is also the same in whatever. It depends. It doesn't matter the number of resistors you have. As long as they are in series, current is the same. Okay, now having said that, if current is the same, it means potential difference is divided. Okay, so the potential difference provided by the battery will be divided amongst these three resistors. Okay, so potential difference is divided. So what do we mean? We mean the total potential difference will be equal to the sum of each potential, the sum of the potential difference of each resistor. So I mean potential difference of resistor 1 plus potential difference of resistor 2 plus potential difference of resistor 3, and so on. Okay, and so on. This is an ellipsis. I don't need to add so many dots. 3 is enough, right? And so on. All right. Now, we said we know, okay, we know R equals V over I. All right. What does this imply? This implies, this side means implies, this implies V is equal to IR. Okay. This implies V is equal to IR. So wherever we see V, we're going to say IR. So now, let's see. I'm going to say I sub total R sub T, I sub 1 R sub 1 plus I sub 2 R sub 2 plus I sub 3 R sub 3 plus and so on, right? Plus and so on, right? Now we said that current is the same throughout, right? So current is not divided. This means current is the same throughout. In a series combination, current is the same throughout. So whether you say I total or say I1, they have the same value. So maybe let's call them all equal to IT. Okay? So I2 is also equal to IT. I3 is also equal to IT. Okay? So whether these guys, I'm going to say IT. Let's see now. So perfect. IT RT is equal to IT R1 plus I2. Oh boy. IT R2 plus IT R3 plus and so on. Remember guys, the reason I'm saying replacing the I1s and I1s, I2s and I3s with IT is because we said current is the same, right? So when we say current is not divided, we mean current is the same. Let me write it here in a different color. Current is the same throughout in a series combination. Okay? Current is the same throughout. Okay? Okay. Because we're saying basically I1 is equal to I total, IT is equal to, they are the same, they have the same current. I mean the current that's flowing here is equal to the current that's flowing here, is equal to the current that's flowing here, is also equal to the current that's flowing here. They have the same values, the same magnitude. Okay? Alright. Now, I want you to see here common factor. You do mathematics, guys. You do mathematics. Common factor. What is your common factor? Your common factor on the right-hand side, it's IT. So check this out. I sub T, R sub T is equal to I sub T. What are you left with? You're left with R1 plus R2 plus R3 plus and so on. Okay, plus and so on. Okay, now dividing throughout by RT, what do you get? Dividing throughout by RT, what do you get? Sorry, by IT, as you can see, dividing throughout by IT, what do you get? You get RT is equal to R1 plus R2 plus R3 plus and so on. So this is the formula that you know. Okay? This is the formula that you know. Okay? This is the formula that you know. Now, I have shown you how we got this formula. Remember, all the times when you do your electric circuits, ask yourself these things. Is current divided? Yes or no? And then you proceed in the manner. Okay? And because we are in resistors in series, current is not divided. It's the same throughout, but potential difference is divided. Okay? So, summary. So, in summary, we will say current is the same throughout. Remember, for resistors in series, current is the same throughout. Okay, current is the same throughout. That's all. First point. Second point, potential difference is divided. Potential difference is divided. Potential difference is divided. Then, what else do we say? Potential difference is divided. What does it mean? It means V total is equal to V sub 1 plus V sub 2 plus V sub 3 and so on. Now, total resistance or effective resistance or equivalent resistance, whichever you call it. Instead of saying RT, I'm gonna call it R sub S to say resistors in series will be R sub 1 plus R sub 2 plus R sub 3 plus and so. So when your resistors in series, okay, hear me out, when your resistors are in series, okay, when your resistors are in series, the total resistance is the sum of the resistors. Okay. Now let's conclude this with an example. Nice, eh? We conclude this with an example. So our example will, let me copy that. Okay, I'm using the very same thing. So let's say, let me paste it. So let's say this guy here is R1. Let's say it's 2 ohms. This guy is 3 ohms. And this guy is 5 ohms. And this one is 12 volts. Okay. So now I will say, let me wait for you guys. In fact, I will wait for you guys, draw this, and then we will proceed. Okay, I will wait for you guys, draw this, and we will proceed. I'll give you 20 seconds. The last time I said 10, it's not enough, so I'm going to give you 20 now. I'm going to give you 20. In Afrikaans, they say 20. I think 30 is reg, so 30 is fine. Is 30 30? Yes, 30. Okay, I've given you 118, but that's fine. So now we will say calculate 1 current in ammeter A. 2, calculate total resistance, or let me call it equivalent resistance, just so you get used to these terms in the exam. Equivalent resistance, and then I'm going to say voltage across a 3 ohm resistor. Okay, voltage across the 3 ohm resistor. Okay. I feel like I should do this. Let this one be number 1 and this one be number 2. Okay, so yeah. So our solution, I'm going to say number 1, I'm going to say RS or RT or R equivalent, it doesn't matter, is equal to R1 plus R2 plus R3. Remember, this is because current is not divided here, right? So we will say this. This means the resistors are in series. So what is R1? It is 2. What is R2? It is 3. What is R3? It is 5. Right? So 2 plus 3 plus 5. What is it? 2 plus 3 plus 5. What is it? It is 10 ohms. It is 10 ohms. Isn't it? It is 10 ohms. So the equivalent resistance is 10 ohms, meaning the total resistance of the circuit is 10 ohms. Isn't it? Now let's calculate the current flowing in ammeter 1. This is the total current. So we know R is equal to V over I. So because here we're looking at the current flowing in ammeter A, right? This is the total current. If we use the total current, we then need to use the total voltage and the total resistance. Okay, what is the total resistance? It's 10 ohms. What is the total voltage? It's 12. What is the current? A, it's unknown. Therefore, I equals 12 over this guy, which is 1,2 amperes. Let me confirm. 12, but it should. 12 divided by it's 1,2 amperes, right? It's 1,2 amperes. Right? Perfect. Now, they say calculate the voltage across the 3 ohm resistor. Voltage across the 3 ohm resistor is this one here. Alright? So what we're going to do, we can say, we know that current is the same. I'm going to do it in 2 ways. So, option one, I know that R equals V over, what is the R? They said across the 3 ohm resistor, Now, what is the current flowing in the 3 ohm resistor? It's that 1.2. The voltage is unknown. Therefore, voltage would be 3 times 1.2, which is 3.6, isn't it? Let me confirm. There's 3.6. So the voltage on the 3 ohm resistor is 3.6 volts. It looks like 3.16. So this is 3.6 volts. Right, it's 3.6 volts. Oh boy, it's ugly. Let me fix it. It's 3.6 volts better. Now, option two, it's what I have been showing you. I said total current, or let's say current flowing in at that 3 ohm resistor, which is I2. I2 is equal to total current. What is I2? I2 is basically from here, R equals V over I. We can say I is equal to V over R, isn't it? So this will be V2 R2. You know the total current, it was 1.2, right? So what is this? What is this V2? V2 is unknown. What is R2? It's 3 ohm. Alright? So V2 equals 1,2 times 3. Therefore, V sub 2 is equal to 3.6 volts. Remember, V sub 2 is the current voltage across the R2 resistor. Say it was going to be this voltage here. Okay. It was going to be this voltage here. Okay. All right. So this is how you answer these questions, guys. This is how you answer these questions. I hope you realize that eventually you get the same things, right? Eventually you get the same things, right? It depends on what you have. You will see the beauty of this later. Okay. So with that being said, ours ends here, and I will see you next time. So with that being said, it's a wrap and bye.